Hi everyone, and welcome to this video for P8105, a course on data science. This is the second in a collection of 3 videos on data wrangling, the process of importing and organizing data for analysis. This video is going to focus on data manipulation and the use of dplyr. I'm going to start by giving an introduction using slides, and after that I'll demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful, and to get the most out of this I encourage you to code along with me. All the material is available at P8105, there are links in the description below. Fantastic, let's get started. I'm going to start by giving an overview of what data manipulation is and what the major operations in that process are. We've seen this graphic a number of times now, and we're mostly focused in this collection of 3 videos on the steps that are right over in here in import, tidy, and transformation. The first video focused on data importing, and now mostly what we're talking about are various transformations that we're going to do. The third video is going to visit this step here in the middle on tidying data and really what we mean by tidy data in the first place. In that transformation or in the data manipulation process, there are a few things that you're going to be most interested in being able to do. And I'm describing these steps in the context of a data rectangle, which is really the data structure that we're going to be most interested in. A data rectangle meaning you've got some structure where the columns are going to be variables and the rows are going to be observations. And we're going to spend a little bit more time talking about what exactly that structure means when we talk about tidy data in the next video. But for now, let's just sort of assume that we're dealing with a data rectangle, and in R, we've got this organized into a data frame. The things that you're going to be most interested in doing in that data rectangle are selecting relevant variables, and by relevant variables I mean columns. What are the columns you need to keep, and do they need to be in a different order, primarily for clarity? Do I need to filter out observations, meaning are there rows in my data, rows being observations? Are there some of those rows that I don't need for the analysis that I'm interested in doing right now, or that are incorrect in some other way? And then given the data that I have now, do some of those variables need to change? Do I need to create new ones that are either some new feature or some combination of variables that already exist? Do I need to create something that doesn't exist? And then again, I've sort of said select, you might sort of reorganize columns. You can also arrange your rows so that things are a little bit more easy to digest. And those typically are not going to change anything that is in your data set. They shouldn't change anything that's in your data set, but sometimes they can be helpful when you're sort of trying to organize things for your own benefit, for your own sake of viewing things. Now, each of these steps is going to be implemented in a particular function in the dplyr package. So here the functions even that we're talking about, right? The dplyr package is going to have functions, one that deals with select, which is relevant for selecting variables, one for filter, for filtering out observations. Mutate is sort of, it doesn't exactly translate to the verbs I was using a second ago, but mutate is basically saying I've got some columns and I either need to add variables or I need to change some existing ones. And then arrange is going to put things in that easy to digest format, is going to sort of put things in order. Couple of comments on dplyr. First is that the author of the package, Hadley Wickham, pronounces this dplyr. I think maybe that's because, I don't know, whether that's a regional thing, he's from New Zealand, I can't bring myself to say it. I always say dplyr. I want you to know that just so that you can make your own decisions about how you want to pronounce this package. The other thing is that this has recently gotten an upgrade. So some of the things that we're going to talk about are relevant for newer elements of this package. The most visual thing that's changed is that the sticker has gotten sort of quite a bit fancier. Now, I also want to talk a little bit about the way the dplyr package is designed. The goal in setting up this package in a way where each function does a particular thing is intentional. The idea here is that if you want one function, if you want to be able to select columns in your data set, well, there ought to be one function that does that thing. And you should have that tool that is designed to do that thing and to do it very well. And that's going to be true for the other functions, right? And it's going to be true for select and filter and mutate and arrange. And then there are a whole host of other functions that exist inside of the dplyr package. And the same sort of modularity is going to be intentional there as well. It's sort of of built in. This is also sort of true more generally, right? We've talked about in the previous lecture the reader package, and the reader package is designed to do all of the things that might have to do with data import. And the dplyr package is designed to do the things that might have to do with data manipulation. And we'll see later on things like the tidyr package, the tidyr package, is intended to do things that have to do with tidying data. ggplot is going to tell us some things about doing data visualization, and all of these are sort of independent components, individual packages that together make up what's referred to as the tidyverse, right? And so throughout all of those packages, the sort of modularity is intentional, and you'll sort of begin to pick up on that maybe a little bit more over time. Now, the other thing in the design of the dplyr package that is intentional has to do with the way you start putting things in and what you should expect those functions to give. In R, functions operate on some inputs, and we're going to refer to those inputs as arguments. And in each of the functions that we're going to look at in the dplyr package, the first argument is always going to be a data frame. So you will take a data frame, and that's the thing that you're going to operate on. And it's the first thing. You always supply the first thing is the data frame, so that when you ask, I need to select something, select from this data frame these columns. I need to filter from this data frame these rows. I need to mutate in this data frame by adding these columns. And it's always going to be that first argument. And that then sort of translates into the output. The output of each of these functions is still going to be a data frame. So you're going to select in a data frame and get a data frame, filter a data frame and get a data frame. And that's very, very intentional because it makes the inputs and the outputs just very predictable. One of the real benefits of that comes when you start trying to connect multiple steps in a data manipulation process. And this is important because data manipulation never consists of a single step. There are always going to be read in the data and clean up the names and then add some variables and filter the rows and select the things that you need and then maybe tidy some things up a little bit. And you're going to want to connect each of those operations in a sequence. Now the design makes this a little bit easier in the sense that you start with a data frame and you use a function that produces a data frame, and then you use another function that expects a data frame and produces a data frame, and another function that expects a data frame and produces a data frame. And pipes are new to R, new in the sense of being new 2014, which in R is still pretty new. The beauty of the pipe operation is that it gives a very clear way to chain together a sequence of actions. And I like to point out that this is new because you probably will still come across code that does not use things like this. And I encourage you as much as possible to adopt this into your own workflow. And just a quick comment, just for the folks who are interested in art history, the package that pipes are implemented in is the Magritte package. And Magritte was a French artist who is famous for the painting here. This is not a pipe when I guess it's a painting of a pipe. And we're not going to get into like why that's a famous painting. I'm not qualified for that kind of thing. But the sticker for the package is a play on the pipe painting. So there, you've learned some art history. Who would have guessed? Okay, so I want to talk a little bit about what pipes do before we start seeing how they work in code. And to do this, I'm going to sort of describe the process, the sequence of actions that go about starting my own days. So I'm like at the beginning of the day, I'm asleep, and the first thing that I do is that I wake up, and then the next thing that I do is I brush my teeth. And then the thing that I do after that is data science. And that is a sequence of actions where I'm sort of transformed by waking up, and then transformed by brushing my teeth, and then transformed by doing data science. And in R, I've got like some pseudo code here. In R, I can nest these actions where the first thing way over here is me when I'm asleep. And then if I've got a function that says, take me when I'm asleep and make me wake up, and then I take whatever the product of this thing is and I put it inside of another function that's going to brush my teeth. And so at the end of this, I've been woken up and had my teeth brushed, and then I'm going to do data science at the end of all of this. And so if I sort of start here, and then I wake up, and then I brush my teeth, and then I do data science, I can save that as me sort of happily doing data science off to the side, right? And this is one way in R that I can go about starting from me being asleep to me being happily doing data science. And there's another way that I could try to do the same thing, which is not nesting this inside of this, inside of this, inside of this. I could alternatively just do this in a sequence and save a bunch of intermediate objects, right? So I could be asleep, and then I could wake up, and I could save that as me being awake. And then I could take that awake version here and brush my teeth, and then I'm awake and I have clean teeth, and that's great. And then I can take that version of me and start doing data science, and I'm happy again. And I want to be clear, these two objects here at the end are going to be the same. So this code and this code both produce the same object at the end, right? But they're both, just really difficult in the sense of writing code in a way that other people are going to understand and that's going to be easy for you to keep track of. What I mean by that is here I've just nested three things, and already looking at this is difficult to keep track of, and I haven't put in more operations that we might do. I haven't put in arguments. Maybe, brushing teeth has an argument for what kind of toothpaste am I going to use? The wake up has an argument for what time am I going to wake up, right? There are other things that might be in here that make this more complicated, and already this is difficult to keep track of. Here, it's a little bit clearer in that I've got a sequence of operations, and that's helpful. I can sort of see each step of the process, but now I've got a whole bunch of intermediate objects floating around. I've got an extra awake version of me and an extra cleaned teeth version of me just sort of floating around. And later on in my code, I might accidentally use one of those versions instead of the version that I actually wanted to use. It just gets difficult when I have a bunch of intermediate objects floating around. So piping is intended to avoid both of those both of those approaches to implementing a sequence of operations. We don't want to have to nest things, and we don't want to have a bunch of intermediate objects. So the way pipes work is, first, I'm going to start at the first operation that I'm interested in, where I'm asleep, and I'm going to wake me up, and then, and that's what this sort of pipe operation is if you're sort of trying to read this out loud to yourself, pronounce this as and then. So I'm going to wake up, and then I'm going to brush my teeth. And I don't have to specify exactly what object goes into here. The pipe is going to say, take whatever came out of this operation and plug it in right here into the first argument of this function. And if there are other arguments, you can specify those. You can say what toothpaste you want to use and things like this, but it's going to take whatever came out of this and plug it in right here. And then it's going to take whatever came out of this step and plug it in here, right? So the process here is sort of the best of both of the previous two things, in the sense that it's clear what's happening. I can see what the sequence is, starting here, waking up, brushing teeth, and doing data science. But also I'm not ending up with a lot of intermediate objects. All of this is going to get saved into that same Happy Jeff object that the other two versions of my code produced. So this really simplifies the process of implementing multiple steps in a data cleaning process and in a data cleaning pipeline, in the sense that I can start with one thing, and then I can say, well, let me select, and let me mutate, and let me filter, and then let me arrange, and maybe I need to select again. I can do all of those by starting with my first data set, and then doing this, and then doing this, and then doing this. And we're going to see how that works. Now again, this works really, really well with the Tibble goes in and Tibble comes out philosophy of the dplyr functions, in the sense that what goes into this is going to be a data frame, what goes into select is going to be a data frame, and what comes out is going to be a data frame, and I can put that directly into the next function. And so the piping structure and the dplyr package and other things in the tidyverse are sort of organized with that in mind. It does, I think initially it takes a little bit of time to get used to pipes. And I want you to recognize that that's just going to take a little bit of processing before it sort of feels natural. But If you are learning R for the first time right now, you may never really understand that the alternative, that these two approaches just are, I don't want to say atrocious, but they're the kinds of things that everybody who has used those in the past, when you start coming into pipes, you just think like, all right, this is great. Now I can code and everything's going to be an awful lot easier. So just, stick with it. Make sure that you understand what's going on, and it's really going to make coding a lot easier. Awesome. So we're going to switch gears and actually implement some of the dplyr operations and pipes in a screencast. Since this is the second video in this collection, I've already done a little bit of work for setting up my project infrastructure. In particular, I've got this data wrangling repository on my computer, and in addition to that, it is connected to a data wrangling repository on GitHub. So all of that work was done in the beginning part of the screencast in the first video in this collection, and I'm not going to repeat any of that. Instead, what I'm going to do, and instead of like going to a course website and downloading a template, I'm just going to copy this or duplicate this data import RMD that was the piece that accompanied the first video in the series. And I'm going to change this to data manipulation. Right now, I'm going to open my R project and open that data manipulation R markdown file and make sure that it sort of accurately describes what I'm doing now. Data manipulation. I'm going to keep in this setup chunk the tidyverse library. I'll comment more on that in just a second, but get rid of the other two. And then I'm going to delete everything else, so I'm sort of starting from a blank slate. And now, just to make sure everything still works, I'm going to knit this. Sounds great. And commit just to say this is starting a new thing. So starting data manipulation. Okay. Now, I'm keeping the tidyverse library in my first setup chunk because now I'm going to be using, as it turns out, two packages in the tidyverse library. We saw reader last time, and we're going to use a reader again just to import an example data set to see what data manipulation might look like. And I'm also going to be using dplyr and loading the tidyverse. Again, the tidyverse is not a package in itself. The tidyverse is a collection of packages. Loading the tidyverse loads both reader and dplyr, as well as a variety of other packages. And so for now, we're just going to make our lives easier and load the tidyverse. Like I said, what we're going to do is focus on a data set that we had seen in the data import part of this collection of videos. So let's load the FAS litters data. And I'll start my code chunk here, reiterating some of the things that we had seen last time. So I want a litters data frame, and I'm going to get this using read CSV and a relative path from my project working directory into the data folder, and then from there get the FAS litters CSV. And just take a quick look. Let's print this in the console. That looks to be about right. And what I'm going to do immediately after this is update the variable names just so that I have something that's a little bit easier to work with. And so I'm going to do the same thing that we saw previously using the janitor package and the clean names function. I'm going to clean the names of the litters data frame and save that back into the litters data frame. And I'll print this again just to make sure everything looks right. And it does. I've cleaned up the litter names. I've now got group lowercase, litter number with an underscore. The sort of special character, the @ sign, has been made to go away. Great. This is the same data set that we saw previously. And I guess I'm not going to go into it in too much more detail right now. Again, group and litter number are characters. GD0 weight, GD18 weight, GD of birth, all of those are numbers. I've got a few missing values in here. I've got 0 weight and 18 weight and so on, right? What I really want to focus on, though, is some of the dplyr operations. And so I guess I'll knit here and commit. This is probably a pretty small commit, but I'm going to go ahead and do it. Import litters. Okay. What I want to do, though, to get started out is to start looking at the dplyr functions. I'm going to do these in the same order that I described in the collection of slides. In particular, we're going to take a look at select first, and then filter, and then mutate, and then we'll just sort of briefly touch on arrange. And then at the end, we're going to spend a bit of time looking at how pipes work. So let's take a look at select. Now, given my data set, I've got all of these columns, and depending on what I'm interested in, I may not be interested in using all of those columns for a particular data set. And that's what select is going to let us do, is choose some columns and not others. So I'm going to start out by taking a look at the select function. And again, the way that dplyr functions, the way that a lot of things in the tidyverse are constructed, is that the first argument into select is going to be the data that I am interested in working with. So I'm going to give it the litters data frame. And what I need to do now is tell select what columns I want to keep. So in particular, let's say I want to keep group and litter number. So I'm going to name both of those. And then if I run this line of code, it's going to pull out, it's going to select only those two columns and nothing else. I could do group and GD 0 weight and keep only those two columns. I can select, let's see, what else might I want to select? I might want to keep group. I'm going to take a look at my full data set and remind myself what I have. Let's say I want to keep group and then GD 0 weight to GD of birth. And so instead of writing out each of those columns, I can specify a range of columns. The way I'm going to specify a range of columns is using a colon from the first column that I want to select up to the last column, GD of birth. And that's going to select the group column and then all of these simultaneously and get rid of everything else. So in particular, I got rid of litter number, I got rid of pups born alive, pups dead at birth, and the number of pups that survived. I can, let's see, what else might we want to be able to do? We can, when we are selecting things from the litters df, instead of keeping, saying what we want to keep, we can specify what we want to lose. And so if we really only wanted to get rid of, say, litter number, I'm going to use a minus sign and then litter number. And this is going to get rid of only that column, but keep everything else in my data set. So that's a pretty handy thing to keep track of. Now I can, as part of this, rename some of my columns. So this is, let's say, renaming. I'm not being really consistent about writing text here. I'm just sort of quickly demonstrating what select is going to do, but let's renaming columns as part of this. So I'm going to select in the litters data frame, and I'm going to rename group, even though it hurts me to do it. I'm going to give this in all caps. I'm going to say that group is equal to group, and let's say litter number is equal to litter number. All right, so again, just sort of changing the way the case structure, going from snake case to who even knows. But what I can do here, like I say, is rename litters, and as part of this selecting process, I can use select to identify columns that I want to keep, and as part of this process, I can rename those. It is true in select that in dplyr that there is a dedicated function for renaming. If you don't want to have to worry about selecting columns and renaming them simultaneously, you can use rename in the litters data frame. And if I just want to rename a couple of columns without doing select as part of this, then I'm going to keep all of those other columns and just sort of rename the two that I had mentioned. Right? So it is sometimes helpful to know that rename exists. You can do similar things with select, but you don't have to. There are a couple of helper functions, and by helper functions what I mean are functions that are used in a very specific context to help you accomplish something, but that you wouldn't necessarily use on their own outside of the context that we're talking about. And so the helper functions that I want to talk about are the select helpers. And I think we can access these using select_helpers as a search term. Let's try here. Nope. This is not going the right way. Here's some of the ones that I'm interested in. all of, any of, contains, starts, ends with, last, names, whatever. So what I'm going to be interested in here is using some of these additional functions, and the ones that I'm going to be most interested in are starts with, ends with, contains, and everything. What I want to use in these select helpers are functions that give me some way of selecting columns that I know I want to keep based on some criterion. And so here I'm going to say let's select in the litters data frame everything that starts with GD, right? So GD, and say GD underscore. So this should, actually no underscore. So this should give me GD0, GD18, GD of birth, but get rid of everything else, right? And so the idea here is that if you have a data set where there are some key phrases that either exist at the beginning or at the end or somewhere in the middle of your collection of variables, well then these helper files, helper functions, give you a quick way to select some of those things. So here I want to select everything that starts with GD, and it's going to give me everything that starts with GD. It is sometimes helpful to know that everything will return everything, and you might ask yourself, well, when does that ever do you any good? If you want to select, for example, in the litters data frame, you know that what you really want to take a look at is litter number as the first variable, but you don't want to get rid of everything else. You can say select litter number and then keep everything, and it will sort of move litter number from the beginning, from wherever it existed to the beginning, and then keep everything else. There's a new function in dplyr, in the version of dplyr that came out extremely recently, which is relocate, and that does the same thing in the end. So relocate in litters data frame, litter number to the beginning, and instead of having to specify everything, it's going to know that you're just trying to relocate this column to the beginning by default. You can relocate, I think, to other positions as well, but I want to relocate this column to the beginning and not do anything else, and that's maybe helpful to know that it exists. Again, I guess the sort of the point that I want to make here is that the key function that you're going to want to use is select. Select is going to do a lot of the things that you need to be able to do, but there are other functions that sort of duplicate to some extent the kinds of things that you can do in select. And so if you find yourself remembering down the road that rename exists or that relocate exists or that some other function helps with a very specific topic, well, that's a helpful thing. I guess the other thing that is useful to know about the existence of both rename and relocate, and by extension other things, is that if you are asking yourself, how do I do this specific operation? Often there is a function that does that thing right now. You just have to know what it is or know how to Google for it. So you might say, I need to move a column around. Let me go to Google and type rtidyverse move a column in a data set, and hopefully something either like select here or more recently like relocate would show up and tell you this is how you're going to do that thing. All right, and I think with that, I'm done selecting variables, at least for now. So I'm going to knit this and let's commit. All right. The next function that we're going to take a look at is filter. Now again, filter is intended to keep track of, is intended to remove rows or keep rows that you are interested in retaining for some subsequent analysis, right? So select kept every single row every time we did everything. It just reduced or changed or reorganized the columns. Select operates on columns. Filter now is going to operate on rows. One of the things that complicates filter, at least in contrast to select, is that instead of giving it just a variable, you have to give it some condition, something that is either true or false. And if it's true, then those rows are going to be kept. That the rows for which the thing you're saying needs to be true, if that's true, you're going to keep those rows. But it's not as simple as just sort of saying, I want to name a particular variable and everything's going to work out. So what do I mean by that? So let's take a look at filtering. Still, I need to tell it which data set, litters data frame. And let's take a look at GD0 weight. This is gestational day 0 weight. This is the first day on which the mother is pregnant. The weight of the mother on the first day that she is pregnant. Gestational day 0 weight. And let's say I want to look only at gestational day 0 weight less than 22. So I'm going to filter this, and in the end, what I am left with is only 8 observations out of those original 49 for which gestational day 0 weight is less than 22, right? It's kept all my other columns. It hasn't selected anything at the same time. It is just filtering rows based on whether or not this observation is true. I might filter in the opposite direction. I might say, let's take a look at gestational day 0 weight greater than or equal to 22. And that's going to give me 26 rows. You might be asking yourself, well, what happened to all of the other rows? There are a lot of observations in gestational day 0 weight that are in A, and so we're sort of missing some number of rows based on that. We can do a variety of other filtering operations. Most of the challenge in filter comes from understanding how you can construct things like this, things that give me some condition that is either true or false. And so there's a collection of what are referred to as logical operators on the P8105 website, on the page that corresponds to data manipulation. And I encourage you to spend a little bit of time looking at that, but I'm just going to run through a few quick examples here. So we might want to say, let's keep everything where the gestational day of birth is equal to 20. And you'll notice when I say is equal to, I'm using 2 equal signs because I'm not trying to say that this variable, to make this value go into this variable, I'm trying to ask a question, are these 2 things equal to each other? So the 2 equal signs is a test for equality. And so if I check this, it's going to say, here are the 32 observations where the gestational day of birth is equal to 20, and it's constant everywhere there. We've looked at less than, greater than, equal to, some other things like this. There are ways to negate the things that we're interested in. And so what I'm going to do next is, again, filter litters df. And I'm going to start by saying gestational day of birth is equal to 20. And now what I'm going to do is say, let's do everything that is not that, right? So I'm going to sort of construct a logical operation that says, see where this is true and see where it's not true, and then flip both of those. And to do that flipping, I'm going to put an exclamation point on the outside of that logical operation. And so this is going to give me all of the pups where gestational day of birth is not equal to 20. And I could do a similar thing in some of these other cases. There is a special way of doing this when you're looking at equality. You can use exclamation point equals for not equal to. The more general structure that I showed first is going to work when you have more complicated kinds of things. And so let's sort of take a look at what I mean by both more complicated kinds of things and then also something that might negate that. So let's do filter litters df, make sure I spell this correctly, and let's say I want 2 things to be true at the same time. I guess we'll sort of keep things at least relatively simple. I'm going to say I want GD0 weight to be greater than or equal to 22. And I also want, comma, another thing to be true. I want gestational day of birth to be equal to 20. So I'm going to run both of these at the same time, and it's going to give me a slightly different data set from what I'd seen before. So I still get now both GD of birth is equal to 20, and I'm looking at gestational day 0 weight is greater than or equal to 22, and it's sort of working in all of these. And I could sort of combine these into a single condition and say I want this and this to be true, and I could put parentheses around all of those and then put an exclamation point to say everything where that's not the case. That's starting to get a little bit, I mean, that's just sort of showing off with logical operations. There's no real reason to get into that level of detail. You should ideally be able to specify the things that you want to keep in your data set relatively directly. And so that's mostly what we're going to take a look at. I guess the last thing that I'll point out, though, is instead of numeric variables, what if we were talking about something else? And so if I wanted to look at filter litters df, and here I want to do something that has to do with group, and I'm going to start with 2 equals. I'm going to say I want to know where group is equal to con 7, and that's going to give me these 7 rows. I could change this to the mod 8 group, and it's going to give me a different 7 rows. I could ask for 2 things simultaneously, so I'm just going to copy and paste this. If I wanted to say that group is equal either to con7 or mod 8, that's going to get a little bit complicated if I'm using these 2 equal signs, but it turns out that there's a handy way that we might specify that, and that's using %, the word in, and %, and then I just need to list the options that I'm interested in. So I'm going to join using C, con7, and mod 8. So this is just this little bit. The C, con7, and mod 8 is going to give me a vector that includes both of those, and this entire operation is going to say where group is either of these 2 options. So in the end, I'm left with a data frame that says either con7 or mod 8, and here are the rows where that turns out to be true. Again, the real challenge in using filter is not in filter itself. The real challenge in using filter is understanding how you might specify, or coming up with a way to specify the collection of rows that you actually want to keep. Understanding both the logical structure, thinking to yourself, well, what do I need to write down to make sure that I'm keeping track of everybody that I want to include in my data set, and then also understanding how you need to implement that using R's way of constructing these logical operations. So, all right, I'm gonna knit this, and then we're gonna wrap up with filter. Let me commit while I'm at it. Okay. So the next thing that I want to take a look at is mutate. Mutate is going to allow me to create some additional variables. So let's take a look at mutate next. Mutate is going to allow me either to modify an existing variable or create some new variable, right? So the things that we might want to create here, I'm going to start out and say mutate, again, in the litters data frame. And I'm going to do a couple of things here. The first thing that I'm going to do is, let's take a look at the weight gain, the amount of weight that these mother mice gained over the course of their pregnancies. So I'm going to say weight gain is equal to whatever their gestational day 18 weight, which is about the time that they gave birth, minus the gestational day 0 weight, which is when they were first pregnant. And if I mutate, I end up, it's sort of way over here at the end. I have weight gain is equal to the difference between gestational day 18 weight and gestational day 0 weight. Does that look to be about right? About 15 here, about 15 here, and so on. Yeah, we could view this data set if we really wanted to, but we're not really going to worry about that so much for right now. The next thing that I'm going to do is first note that you can change this. I could get rid of this condition and I could mutate in a different way, but what I can do instead actually is mutate by adding multiple variables at the same time. And I'm gonna, just to make this formatting look a little bit better, I'm gonna make sure the indentation works the way that I want it to. So the next thing that I want to do is, after adding first this weight gain variable, I'm going to change an existing variable, the group variable. And this is something that I might do if I were actually working with this. And this is going to rely on a function that I know exists. What I'm going to do is make the variables in group lowercase. All right? And so I'm going to modify the group variable. I'm going to modify the group variable by making everything lowercase, and simultaneously I'm going to overwrite that group variable with a modified version. So the main points that I want you to take away from this collection is, first, that you can create a new variable. Second, you can modify an existing variable, and you can do as many of those mutate options of creating variables or modifying variables as you need to be able to do in one of these mutate commands. So I'm going to highlight all this, run it, and you see here group has now, instead of being uppercase C, con 7, and con 8, is now lowercase. This is a relatively small change. Weight gain still exists here at the end. New variables that you create always get sort of tacked on to the tail end. Modified variables stay where they were. So weight gain is new and it's off to the side, and group is here. Right? So that's great. That's mutate. And I'm going to knit. And that's the wrong one. Commit. Okay. So the next one is sort of like mutate, is going to be relatively quick. The next thing that I'm going to take a look at is arrange. And in arrange, the goal here is to put things in order. And the reason that I say that this is going to be relatively quick is first because I think putting things in order is pretty intuitive, and second because it's just not one that I use all that often, right? And the reason that I don't use arrange all that often is because putting things in order is primarily something that you need to do if you are updating a data set or something like this, to inspect it in a way that is a little bit more intuitive than just whatever's been put into the data set. That shouldn't change any of your actual data analyses. It shouldn't change any of your results. It shouldn't change any of your models or your plots or anything like this. It is sometimes helpful to make sure that you know what's going on in a data set, and it is sometimes helpful if you have compressed some results, you've got some model output that you want to express somehow. Arrange is useful in a couple of cases like that, but I just sort of want to point out what it does, and we're not going to spend a lot more time on it than that. So the same structure, I'm going to arrange the litters data frame, and let's just sort of arrange the litters data frame by pups born alive, right? So now I've got here pups born alive in order, and you can't see everything here. I've got 49 rows and 8 columns, and I guess I've got pups born alive 3, 4, 5, 5, 5, 5, 5, 6. It looks like it's in order. We could, again, view the entire data set if we wanted to, but I'm not going to worry about that so much right now. So that's arrange, and that's you can put it in reverse order. You can arrange in alphabetical order if you want to do group first. You can arrange by 2 variables simultaneously, so maybe just to see what that looks like, let's do pups born alive and then GD0 weight. And what you get out of that is that first you're in order by pups born alive, and then within each of these levels you're in order for gestational day 0 weight. So 3 and 3, that looks like it's in order. 5s are all in increasing order. 6s look like they're increasing, right? So you can organize data. Again, not trying to downplay arrange. It's a helpful thing, but it just doesn't come up as often as some of the other ones. So I'm going to end with arrange here. And that doesn't get any exclamation points in my commit message. It's fine. It's okay. What I am going to be a little bit more excited about and interested in is the pipe operation here, and this is where we're gonna sort of take a step back and think about various ways that we might have introduced a data processing pipeline. And I'm going to start that data processing pipeline from the very beginning. And what I mean by that is I'm going to say what would happen if I wanted to import a data set and then clean the names and then select some variables and then maybe do a mutate step, and then let's do like a filter operation, and then we'll sort of see what happens beyond that. Okay, and each of those steps I think is important. Each of those steps is very natural in the context of a data processing pipeline, but I want to first show how not to do this, and then I'm going to show like how this might actually work. So again, I'm going to insert a code chunk, and let's just sort of, for the sake of argument, say that I want my litters data set, and the raw format is going to be reading in read CSV from the data FAS litters.csv. And then the next thing I'm going to do is create a litters clean name by using janitor clean names on this this thing right here. So I'm going to copy and paste that. And then I'm going to say, let's take my litters data frame, litters data with selected columns. And I'm going to take whatever this thing was. Let's select from this everything except for pup survived, right? And right now I'm going to stop and make sure that this is actually working. So that read in the data, that seems like it's worked. It says pup survived doesn't exist. Litters data selected not found. Oops, sorry. Clean name. Pup survived. Oh, I've got an extra survived not survive. Okay, that looks like it works. All right, so that's working, right? So I've read in my data, I've cleaned the names, I've got pups survived. Let's do litters mutated, and so I'm going to take mutate the selected columns, and let's just add my weight gain variable for GD18 weight minus GD0 weight, and let's see if that works. Litters mutated, should have added a column at the end, and it sure did. And then just to sort of both emphasize that we can continue with this process and also to introduce a particular function that is helpful in the context of filtering, what I'm going to do is litters without missing data, and I'm going to take, I could use a combination of filter and a function isNA and probably a negation of this, but what I'm going to use instead is a dropNA function. This is one that exists in the dplyr package, or possibly in the tidyr package. What I'm going to drop is from litters mutated, everything where data are missing. And I could be a little bit more specific, and let's say everything where GD0 weight is missing. Okay, and let's check out litters without missing. So I've gotten rid of all of the rows where GD0 weight is missing, and I've still got some missing values in GD18 weight. If I got rid of this line, it would get rid of everything that's missing, but I'm gonna keep the ones where GD18 weight is missing. All of this is to say, I haven't done any pipes yet. All of this is to say, this is one process that you could use to start by reading in my data set, and then cleaning the names, and then given that, selecting some variables, and then mutating, and then getting rid of the missing values. And I could do this, I'm not going to. I could do this by nesting this function inside of this function, inside of this function, inside of this function, inside of this function. Again, I could nest all of those and take my word for it, or for an example, go to the course website. That's going to be really, really gross to take a look at. So what we're going to do instead is use the pipe, let me all caps this, use the pipe operator instead. This is critical. So what I'm going to start out with is just say at the end, I want a litters data frame, and I'm going to set this equal to whatever comes out of the piped together collection of commands that I'm interested in. So for this example, the first thing that I'm going to do is read CSV from my relative path data fas litters.csv. And then I'm going to use the pipe operator to say, do this and then do the next thing. Now, this is another example where I encourage you to learn your hotkeys so that you're not typing like shift parentheses greater than parentheses every single time. There was a student last year who referred to that as grapes greater than grapes, but we're going to call this the pipe. Now, the hotkeys that I'm going to use are shift command. You know what? It's really difficult when you're trying to remember the hotkeys when it's just something you usually type naturally. I think it's shift command M. Great, got it. So for a Mac, shift command M, it might be shift something like that M on a Windows machine. That's going to give me the pipe operator. So here I've got read CSV, read this in. Just running that line should give me the data set, and it does. And I'm going to say, and then use janitor clean names on whatever came out of this operation. So if I run these two things together, it should say do this and then do this, and it does. And I haven't saved anything yet, right? This is just sort of printed in the console, but I'm reading in the data and then cleaning the names. And then, what was my next step? I'm going to select, and here's where things get a little bit sort of strange. I didn't have to put anything here and clean names like I did here, because the pipe sort of says whatever your first argument was, that's going to be whatever comes out of this is going to be your first argument here. You don't have to repeat anything. So I'm going to select, and I don't have to repeat anything. It's going to know to select given whatever came out of that previous step. I'm going to select everything except for pups survive. And I can check this stage. That's working, and it's gotten rid of that last bit. Now again, it sort of knows that the first argument into select should be a data frame, and it'll use whatever data frame came out of janitor clean names. And then I'm going to mutate, and the variable that I'm going to create is weight gain by using GD18 weight minus GD0 weight. And then I'm going to drop the missing values in GD0 weight. And again, the same sort of process that I used for select is going to apply both to mutate and to drop NA, which is to say whatever comes out of select, the data frame that comes out of these first three steps is going to be the data frame that mutate uses, and then whatever comes after this line is going to be the data frame that drop NA uses. So if I run each of these lines, I should get, again, that same data frame that came at the final step here, litters without missing. These two are the same, but this collection of code that creates my cleaned litters data frame is going to be much easier to read. It's going to be a lot easier to take a look at. And that, I think, is just a huge benefit in using the pipe to string together collections of commands. Now, I'm not going to draw too much attention to this, at least not right now. There is a way in the pipe to be more explicit about where the data frame that comes out of this point goes in the collection in the function that comes immediately after it. You can use what's referred to as a placeholder to say, take this select, or take whatever comes out of these first three steps and put it into a very specific place in mutate. That doesn't really matter in any of the functions that we're looking at so far. Down the road, if you're trying to use, for example, one of these things in the context of fitting a model or doing something outside of the tidyverse as a part of the data processing pipeline, then it becomes a little bit more relevant. But for now, that's not something that we're really going to worry about. Instead, the main takeaway from this video is going to be the main functions in the dplyr package. That's select, filter, mutate, and arrange. We'll talk about some other functions in dplyr down the road a bit, and then also understanding how all of these pieces start to fit together into a collection of steps in a data processing pipeline, so that you can both read in data using something in the reader package, clean up the names, use select and mutate, and drop in a and filter, and whatever else you need to use in a sequence of commands that are all put together using these pipes. So focus on that for now and get some practice on that. And with that, I'm going to go ahead and end. Thank you very much.